Hi, my name is Ben Sullivan. I'm here at ARSL, UMASS Lowell's Autonomous Robotics Systems Laboratory, which is a mechanical engineering department laboratory run by Yanis Raptis. Here I'm going to show you a brief overview of a spider bot, which can be seen here. A spider bot is one agent of the multi-agent autonomous robotic system, the Arachne-System. What a multi-agent autonomous robotic system is basically a system of multiple robots, this is one, working without human input. This is the autonomous part. This system was developed by UMASS Lowell, students such as myself, and it can be used for a wide variety of purposes. Spider bots are also very modifiable. As you can see, here's a spider bot with an infrared vision system. As you can see, there's infrared lights on these. This can be used for another type of collision avoidance. Examples of this can be found, as well as examples of all the algorithms we developed, and examples of the Python scripts and everything we've done in Robotics. Tutorials can be found for all of it on the webpage. Alright, I'm going to be showing you how to construct your own spider bot. The first step in this is to construct the spider body. A completed spider body can be found here. What you're going to be needing for this is a hex bug spider, seen here in its packaging, 2 colors of wire, any 2 colors will do, doesn't matter, a Phillips head screwdriver, it's a 2.0 millimeter screwdriver. That doesn't need to be exact, as long as you're somewhere around there in your size, you should be good. You're going to be needing wire cutters, and also a hook glue gun. Alright, so the first thing you're going to do is dismantle the spider. So first, you'll see the spider has a lid on it. What you're going to be doing to remove that lid, turn it upside down, you'll see a small screw here. Unscrew that screw, top will come right off. Once you open it up, you'll see 3 more screws. Again, you're just going to stick a screwdriver in there, unscrew them. This can be a little tough, but shouldn't have any trouble. You also notice that when you take it off, it might be a little bit stuck. You can see this black thing next to this red part. Just push that out with a screwdriver, and the body should come off. Once you've removed the head, you'll see some circuitry here. 4 wires coming off that circuitry to the spider bot, and 2 red wires going to the spider head. All you're going to be doing, take your wire cutters, and just remove that circuit board. Just like that. You'll now have 4 wires. You'll have a black wire and a white wire coming out of the middle of the spider, and a black wire and a white wire coming out of the side of the spider. What you're going to do now is, taking your 2 colors of wire, cutting off a reasonable size length, a good size length to be found here, just an inch or 2, stripping the end of that wire, and soldering it to here. You want to make sure your colors are consistent. If you have, say, I'm using black and blue, I could use the black wire on the black wires and the blue wire on the white wires. Once that wire is connected, all you need to do, take your hot glue gun and wire these thin wires to the spider. This is because the thin wires are very delicate, they can easily rip. We use thicker wires, solid wires, because much less chance of ripping. It makes the spiders much more usable. Make sure though, when you glue them down, you know which 2 wires are coming from the center of the spider and which 2 wires are coming from the side of the spider. That will be important later. Once you've done all of that, you should be left with something like this, which is a completed spider body. As you can see, there's 4 solid wires coming off, a red and a black for each side. You can tell which ones are coming off the middle, and you can tell which ones are coming off the side. Now your spider body is complete. Once you've completed your spider body, the next step is building a spider head. This is the completed spider head. High-resolution images of this are included. You're going to be needing the following parts to build the spider head. Links to all of these parts can be found on the webpage. First, you're going to be needing some pin connectors. These are basically just for connecting the pan stand, which of course you'll also be needing. You're going to be needing a motor driver. You're going to be needing a LiPo battery, charger, and connector from SparkFun. You're going to be needing 2 motor connectors. You're going to be needing a green LED, and you're going to be needing a round circuit board. Also, you're going to be needing some wire. Again, any wire will do. Use solid, not stranded, as long as it's a relatively small gauge. Okay, so the construction of the head is relatively simple. All you need to do is basically solder it on. If you need instruction with soldering, SparkFun and a few other websites have a lot of great tutorials on it. Just Google it. This is only through-hole soldering, so you don't need to worry about variable temperature or anything like that. Alright, so in actually constructing the spider head, it's relatively simple. You're basically just going to be following a schematic. If you need help following a schematic, there's tutorials available online. It's relatively simple. There are a couple tips I'm going to give you though. First is cutting the pins. When cutting the pins, you're going to want to cut them appropriately to the length of the pan stamp. Basically, get a wire cutter, get the pins, get a pan stamp, put the pan stamp into the pins, and now cut in the middle of the pin right after the pan stamp. This should give your pins the perfect length. When connecting the pins, it's important to connect the motor driver first. Basically, just place the motor driver in the middle of the board, solder it down, and then place your pins in. Because as you can see, the pins are around the motor driver. It's very difficult to solder the motor driver second, sometimes it won't fit. It's much easier to solder it first. There's also a slightly tricky part with the light bow connectors. As you can see, in a completed spider head, they're stacked on top of each other. This is easy to replicate, but might not be obvious. Basically, all you're going to need to be doing is either take a stripped wire or pins, as can be seen here. Even these pins will work if they're long enough. Basically, place the charger on top of the connector and place pins from the holes in the charger through the holes in the middle of the connector and solder them both in. You can see in the images of the spider head, this is how they're constructed. Relatively simple. Outside of that, it's basically just following the schematic. It's not just going to be putting the parts in, of course you have to solder the parts in, but there's also some wiring. It's nothing too complicated. There are images of a completed spider back if you want to copy our build exactly and you are having trouble reading the schematic. So once you've done that, the spider head should be complete. Once you've completed the spider body and completed the spider head, all that's left is connecting them. All you need for this is the two parts you've already completed, a small flathead screwdriver, and a hot glue gun. All you need to do, place the spider head on the spider body, like so. You're going to want to be connecting the red wires, which are the white wire, which correspond for me to the white wires on the spider, on the left, and the black wires on the right of each one. You're going to place the wires that come out of the side of the spider to the right side of the spider board, here. And all you have to do is screw those in using your flathead screwdriver, just like so, very simple. Then once those are screwed in, all you need to do is hot glue the body on for security. After you've done this, just place your pan stamp in, and your spider is good to go. It's important to note that pan stamps, if you get a certain model, they won't come with an antenna. All you can do for an antenna is solder an antenna on to the middle of the 3 copper strips on the side of the pan stamp. As you can see, this is the pan stamp with an antenna connected. If you would like to know the correct length for your antenna, check the pan stamp website. It has very much information about that. I believe we use 3/4 of an inch for our purposes. The Arachne-System is split into 3 main parts. First, we have the vision system. The vision system is basically just an ordinary webcam. It's going to be placed above the robots. You can see the particular build that we've used in our experiments. Images of that are included. This webcam is connected to a computer, which is the second part of the system. The computer is running a software known as RoboRoam. RoboRoam is a vision software available to the public. It has many uses, but in our situation, we use it to track fiducials. You can see a fiducial here, it's an image in the middle. Basically just a unique image. RoboRoam can use it to track both the position and the orientation of the image. This image is then processed by RoboRoam and sent through a Python script to the agents themselves, the final part of Arachne-System. The agents themselves actually process information and decide what to do with it. The agents do this wirelessly through something known as a pan stand. This is a pan stand. It's basically just an Arduino unit that utilizes radio communication. It's programmed just like a normal Arduino. It's placed on something called a pan stick, which you see here. Place it here. It's USB, put it into your computer, and you send the code to it. This is placed then directly on the spider. And the image, and now the spider is ready. It is peer-to-peer communication and also communication with the main computer, where your pan stamp is also connected. We have developed 4 main algorithms for the spiders. The first is set point control. Basically, so a spider can get from point A to point B. We've also developed a collision avoidance algorithm. So these two spiders are going to be moving. Say their targets are on each other. Instead of just crashing into each other and not working, they will get to within a certain distance, avoid each other, and get to their final location unscathed. Third is a single object manipulation algorithm. Basically, the spider push objects such as this, from point A to point B. We also have group manipulation, in which multiple spiders, and the algorithm we developed for these 4 spiders, are used to move a larger object that one agent could not move very effectively.